This is part 20 of Entity Framework tutorial. In this video, we'll discuss implementing table per type inheritance in Entity Framework with the database first approach. In parts 18 and 19 of the Entity Framework tutorial, we discussed how inheritance hierarchy can be represented using table per hierarchy. With the TPH, one database table is used to store data of all of the entities in the entire inheritance hierarchy. The downside of this is that we have a denormalized table, and some columns will have null values depending on the type of the derived entity being saved to the database table. If you recollect from parts 18 and 19 of this video series, these are the three entities that we worked with. So notice that here we have the base employee entity, and then permanent employee and contract employee. Both of them derive from this base employee entity type. Now, when we are storing this permanent employee entity data, permanent employee will have values for annual salary column, but not for hourly pay and hours worked column. So both of those columns will be null when we save a permanent employee entity. Similarly, when we store contract employee entity, contract employee will have values for hourly pay and hours worked, but not for annual salary. So depending on the type of entity that we are storing to this employees table, some columns will have null values because this employees table here is a denormalized table. In TPT inheritance, that is in table per type inheritance, one database table per type is used to store data of the entities in the inheritance hierarchy. Notice that here we have the same three entities, and on the left hand side, to store the data of these three entities, we have got three tables, that is one table per type in this inheritance hierarchy. So to store the data of the employee entity, we have got employees table. Similarly, to store the data of permanent employee entity, we've got permanent employees table, and for contract employee entity, contract employees table. If you look at the relationship between these three tables, employee ID is the primary key column within employees table, and within permanent employees and contract employees, employee ID is the foreign key column. Now, when we store permanent employee entity to the database tables, now the data of the permanent employee is going to go into these two tables. Permanent employee will derive ID, first name, last name, gender properties from the base type. So the values of those properties is going to go into employees table, whereas annual salary property value will go into permanent employees table, with employee ID column being the link between these two tables. And similarly, when we store contract employee entity, ID, first name, last name, gender property values will go into the employees table, and hourly pay and hours worked property values will go into contract employees table, with employee ID column being the link between both of these two tables. Let's look at this in action. The first step here is to obviously create these three tables, which I have already done. Here is the SQL script that can do it. I'll have the script available on my blog in case you need it. Now let's flip to Visual Studio. Here I have an empty ASP.NET Web Application project. Let's go ahead and add a new item to this project, and the item we want to add is ADO.NET Entity Model. Let's call this Employee Model, and we want to generate the model from the database, so select that option, click Next, and let's give this connection string a meaningful name. Let's call this Employee DB Context. Click Next. This is going to connect to the database and retrieve all the tables, views, and store procedures. And we are interested in these three tables. So let's give this model a meaningful namespace. Let's call this Employee Model. This is going to generate the entities for the three database tables. Now the interesting thing to notice here is that between the entities, instead of an inheritance association, there is a foreign key association. Okay, that's because if you look at the tables within the database here, they have a primary key foreign key relationship, and Entity Framework by default is going to generate that association between the entities. And also notice that this employee entity has got two navigation properties, that is contract employee and permanent employee navigation properties. So contract employee navigation property allow us to navigate from employee to contract employee. Similarly, permanent employee navigation property allows us to navigate from employee to permanent employee. Now we don't want a foreign key association between the entities. Instead, we want an inheritance relationship. So to achieve that, the first step here, let's go ahead and delete this foreign key association. Now look at this. When we delete this association, it will automatically remove the navigation property as well. Okay, so let's go ahead and delete that. Look at that. As soon as we deleted that, the navigation property is gone. Similarly, when we delete this association, the other navigation property is gone. Now let's go ahead and add an inheritance relationship. So select inheritance here, and here the base entity is going to be employee entity and the derived entity is going to be contract employee. So when we click OK, that should establish an inheritance association between employee and contract employee. Now look at this little arrow here indicates that this contract employee is deriving from employee entity. Okay, similarly, let's add the inheritance relationship between permanent employee and employee. So again, the base entity will be employee and the derived entity will be permanent employee. Alright, so now if you look at the diagram here, both contract employee and permanent employee are deriving from the employee base entity. Okay, now since employee entity is going to be the base entity for these two entity types here, we don't really need to have employee ID property again both in contract employee and permanent employee. Why? Because since both of these entities are deriving from employee entity, they will have employee ID property available through inheritance. So we can get rid of this employee ID property from both of these entities. Now let's validate the model just to make sure it is valid. So notice that it says validation completed. Now let's add a web form to this project. We'll look at how to query this model. Now for that purpose, we are going to design a web form that looks like this. So let's go ahead and first set style attribute here. Let's set font family to Arial, and let's drag and drop a radio button list control onto the web form. And radio button list is a collection of list items, so let's add a list item. Let's set text equals all employees, and let's say value equals all. Similarly, we need to add radio buttons for loading permanent employees and contract employees, just like this. And to speed things up, I have already typed the required HTML, so let's copy and paste it right there. So here we have a list item to load permanent employees and a list item basically to load contract employees. The next step is to include a grid view control, so let's drag and drop a grid view control, and let's actually flip this to the design mode and auto format this grid view control, and let's set auto post back for the radio button list to true, so that it will automatically post back when the selection changes. And to speed things up, I have already implemented the code, so I'm going to copy this code and paste it within the radio button list selected index change. Now we discussed this code, this exact same code, in parts 18 and 19 of this video series. So if you want an explanation of this code, please watch that video. Now when we go ahead and run this code, we should get the interface that we have seen on the slides. So when we say all employees, it should load all the employees. Okay, notice that we have all the employees here, and when we select load permanent employees, it should only load permanent employees. Similarly, when we load contract employees, only contract employees. Now when we say all employees here, notice that it's showing only employee ID, first name, last name, gender, columns. That's basically because if you look at employee entity, that's what we have got within employee entity. So those are the properties of the employee entity. Now when we selected load all, which is the case of default, we are storing the list of employees. And if you look at the employee entity, they have got only ID, first name, last name, and gender properties. Now, if you also want, annual salary, hourly pay, and hours worked, to be displayed on the web form, then you will have to do that, maybe by using a data table, which we have seen again in parts 18 and 19 of this video series. So what I'm going to do here is, again, to speed things up, I have a private function here where we create a data table, copy and paste this function within the code behind file. And again, if you look at this function, this is a straightforward function. First of all, data table type is present in system.data namespace, so let's bring that in. So this private function right here, it returns a data table. Now what are we passing to this function? List of employee objects. So we are creating a data table here with all the columns that we need: ID, first name, last name, gender, annual salary, hourly pay, hours worked, and whether if it's a permanent employee or a contract employee. Okay, and what are we doing here? We are looping through each employee object in the collection that gets passed to this method, and then we are populating ID, first name, last name, gender column values, and then we are checking, is the employee type permanent employee? If that's the case, then retrieve the annual salary property value and store it in the annual salary column of the data row. And then if it's permanent employee, store permanent as the value within the type column of the data row. If it's not a permanent employee, then retrieve values for hourly pay and hours worked, store in the respective columns, and then set the type to contract, and then add the row to the data table. Finally return the data table. So we discussed this code in parts 18 and 19 of this video series. And then what we are going to do is, if load all employees radio button is selected, then we are going to pass this employees list to this convert employees for display function. And then it should display hourly pay, annual salary, and hours worked as well. So let's run this. So when we say all employees, so it needs to get data from 3 different tables, that is employees, permanent employees, and contract employees. So when we select this radio button, obviously all the 3 tables have to be joined, and Entity Framework will write that join query for us automatically. Let's actually fire up SQL Profiler and investigate those queries. Let's run a new trace. Right, so let's clear the trace there, and let's actually reload this web form. So let's select all employees, and then permanent employees, contract employees. Let's go to Profiler, stop it, and look at this. Here there's a big query, but basically if you look at this query, it should join all the 3 tables, that is employees, permanent employees, and contract employees. Okay, and similarly, if you look at this query right here, it should join permanent employees and employees, because we are loading only permanent employees. And similarly, if you look at this query, it should join employees and contract employees. That's it for today. Thank you for listening. Have a great day.